Today's edition of PowerWise Design TV is brought to you by Altera. Recently named the best managed semiconductor company by Forbes.com, Altera is the pioneer of programmable logic solutions, enabling system and semiconductor companies to rapidly and cost-effectively innovate, differentiate, and win in their markets. Altera is at the forefront of programmable logic innovation, delivering market-leading positions in power, performance, process technology, density, and system bandwidth. Altera supplies its FPGAs, CPLDs, and hard copy ASICs, as well as software tools and intellectual property to more than 14,000 customers worldwide. Altera. Today's show is also sponsored by Arrow Electronics.
Arrow Electronics provides products, services, and solutions to industrial and commercial users of electronic components and computer products worldwide. All over the world, inside just about everything that just about everybody works with, plays with, or is impacted by, are components provided by Arrow that make them work.
Hello and welcome to PowerWise Design TV. I'm your host, Rick Czar, and today we're going to talk about motion control and motor control technology. As many know, power consumption of motors is a big concern. As a matter of fact, motors make up the majority of energy consumption in industrial applications. So one of the things to do to improve that is to use motor control as a way to improve the efficiency of motors. Today we're going to talk about the Motion Fire development kit that was developed in cooperation with Altera National and Arrow Electronics. I have Jeff Wemmett, the Senior Applications Engineer from Altera with me today. Welcome, Jeff.
Thanks.
And Steve Herhusky, the Senior Field Applications Engineer from Arrow Electronics as well. Thank you so much for joining me today.
Glad to be here.
Great. So, Stephen, what are some of the major problems that your customers are seeing implementing motion control and motor control?
Well, Rick, what I'm seeing in my space is most people using motors are in the industrial space or in the medical space. Mm-hmm. And what they need is they need longevity. They need more than the 5 years offered to them in embedded systems.
Is that because mostly this stuff ends up in manufacturing for long periods of time?
Yeah, they need to support a product for more than 15 years.
Wow.
And they need to lower their risk, make sure that whatever they're controlling a motor with is going to be out there.
Yeah.
And so that's their main concern. They want to lower that risk.
Mm-hmm. Are there any other concerns that they might
Yeah,
have?
they want to make sure they're going to have a lot of code base, so they want
Mm-hmm.
software compatibility during that time. So they want that, and they know that during the 15 years there's going to be improvements in motors, right? So they're going to have change in requirements. So they want their controller to be software compatible, but like I've got customers now, they're going from brush DC to brushless DC. Mm-hmm. So they're changing motors, but they still have to support that code base that was there before.
I see. So, Arrow developed this Motion Fire board. What was the initiative? What spurred that development? Why did they do that?
Well, Arrow has lots of development kits available, most of them from some type of embedded processor doing one or two types of motors. But there's nothing out there that would control multiple motors. And there's this kit right here offers flexibility that just wasn't out there in any of the other kits. And so mainly it was to address the changing needs of customers and offer them the flexibility of getting to market very quickly.
Yes, I see. So this kit supports up to 6 motors, is that correct?
That is, it's actually, in the brush DC motor, it can control up to 6. It can actually control up to 12 motors in different varieties.
Oh, that's interesting. So in developing this kit, how does that address some of the issues that we discussed with some of the problems, especially I guess the FPGA centric nature of the board?
Well, with the FPGA, because it's programmable, you can get some very fast time to market. And you can also meet those changing needs I was talking about earlier. You get that flexibility.
I think that's the two biggest things about using an FPGA in this space. You get the flexibility of changing your code, of accommodating new industrial Ethernet standards. Once you put a PHY down, whatever MAC you put inside the FPGA, you can change over time. You can tweak the design as standards change or new protocols come up that you want to take advantage of. That's a big boon to industrial applications like this that have a really long life cycle.
That's interesting. You know, you bring up an interesting point. You know, with FPGAs, you have a lot of flexibility where you may not have that with a microprocessor or a DSP. Can you talk about that a little bit?
Well, I think flexibility is one thing. The other thing that FPGAs really bring to the table is integration. You have the ability to put multiple control systems onto a single FPGA and then integrate your field bus communications, other processing elements that you may have in your system, and then put an intelligent host behind it all to kind of control and oversee the entire system at once. And that integration combined with the flexibility really makes an FPGA a compelling solution in the motor control space.
Yeah, one of the things you might have forgotten to mention, I think you hit it right with the integration, but customers are also concerned with lowering cost, right? And by integrating, currently they might have a DSP or a microprocessor out there, right?
Or both.
Right, and they probably have some type of CPLD or an FPGA for I/O expansion. Well, now they can, by integrating, they can get the longevity of having an FPGA with a soft processor in there, and they've lowered the cost by removing those other components.
And I think part of that is because of the Cyclone 3 family, which is our Altera 65 nanometer process family, and really combines a lot of functionality for a low cost and for low power as well.
Why don't you talk to that a little bit? What was it that compelled the design to use a Cyclone 3?
Well, Cyclone 3's got a broad range of processing power available to it. So parts from 5,000 logic elements up to 120,000 logic elements. So the family spans a significant range of processing power. And within each FPGA, you've got DSP blocks, 18 by 18 multipliers essentially, as well as embedded memory, up to 4 megabits of embedded memory. So a lot of flexibility within the FPGA and the FPGA family to really pick the solution that's best for the particular motor control application that you're targeting.
So this has a Neo, you said Neos processor embedded inside.
That's the other thing that's great about the Cyclone 3 family is it'll house this soft core embedded processor. And what's really unique about Neos when you compare it to sort of off-the-shelf processors is you can customize the peripheral set that Neos 2 surrounds itself with. So if you want a couple of UARTs and a CAN bus controller, and then you just add those. You need 6 UARTs, you just add those. So it really gives you the flexibility to customize the peripherals that are around the processor itself. You can also add custom instructions to it, up to 256 different custom instructions to the processor. And then to go back to Steve's point about longevity, which is a key concern in this space, the Neos 2 processor is not going anywhere. If you want to migrate it to the next generation FPGA, all your software migrates right along with it.
It's a soft core?
It's a soft core processor. You just recompile it for the new FPGA family and you're off and running. If you need more processing power, you move to a higher end FPGA. You need lower cost, well, move to a lower cost family.
That's very,
one of the things you probably should also bring up, though, one of the things, the reason that Arrow chose this family is because besides the Neos, Altera also has a tool called SOPC Builder, which really promotes ease of use. Customers can quickly put their code and connect it to the Neos processor, and it's very seamless. They don't have to hook it up. It does it for you, basically.
It's a good point. The tool set behind Neos 2 is really one of the things that makes it easy to use on the front end. So the development tools, both Quartus and Neos 2, are key to being successful in this space.
So you Arrow developed this board, so you pulled all of this together to create this kit, right? And we have a video of this kit in action. So why don't we take a look at that video and see it actually doing its thing. Let's do that.
Hi, my name is Steve Husky. I'm a field application engineer at Arrow Electronics. Today I'm going to show you a short demo of Arrow's MotionFire motor control board. And the kit you would get consists of 2 boards. It's this firefighter board right here and a fire driver board. They're kind of hidden behind here. Got one brought out here. This one comes with, you can see some of National's PowerWise gate drivers that they use for driving the motors. They come out these connectors over here. We also have some of National's A to Ds that monitor the voltage and current. You can see them displayed up there. And you can see right now they're driving a brushless DC motor that comes with the kit, but you can obviously take off this one and put on your own motor out here. The kit can drive many different types of motors. On the system, All right, so let's go over some of the components on the firefighter board. To make it easier for the camera, I've got another board right here, and let's go over some of these. So National has provided all the DC to DC regulation that we needed with some components up here, some nice linear regulators and stuff. Altera is this is the heart of the system. This is their Cyclone 3 FPGA, and inside is the Neos processor that's doing all the controlling of the motors we have. Altera also has a Max 2 part on here that's basically for I/O expansion on the board. And down here, probably the other components you want to know are we've got these Ethernet, and we've got National has some great PHY chips for those. And that's about it on the firefighter board. Today I'm going to control this firefighter board with Altera's NEEK kit. That stands for Neos Embedded Evaluation Kit. And this kit also has a Cyclone 3 component on it. And I'm going to use the nice touchscreen display here. It drives out VGA, and I've got it displayed over there, so hopefully you guys can look on the big display while I touch the buttons on this one. But let's just get started and control one of these motors. You can see I've got 3 motors I can select between. I'm going to select the center one because that's easiest to video. And we're going to change the position on that one. So let's give it a component on how fast we want it to turn. We'll say 5,000. We'll hit OK. And how fast we want to accelerate to that speed. We put in again 5,000. Hit OK. And it takes 2060 to make one encoded revolution on there. So I'm going to make it 2 turns. I can put 4120. And if I do it right, it should make 2 turns around and stop. And if I go back and put in 0, it should turn back the other way. And let's have it do that. And it stopped. So now I'm going to just for sake, just make this motor turn here, and I'll just make that one turn continuously. That is motor 1. And again, I'll put in a set my parameters on there. I'll just 40 for my speed parameter and 50 for my current parameter. And I'll set a speed fast forward, how fast I want to turn. I can make it turn very slow to start with. And hit OK. And now I'm turning. Should probably take this time to thank the people who made our nice demo here. This is from SLS, which stands for System Level Solutions. And I could make it go faster by giving the speed. I've kind of completed the short demo I was going to do today on the MotionFire board, but what I wanted you to get out of it is we are using Altera's FPGA, and we can control multiple motors. And what's different about this is with the FPGA, we can control these motors very quickly, very tight loops. And with that, you'll get substantial power savings of your motor control system, something that you can't normally do with just your microprocessor controlling motors. So I hope you enjoyed the demo today, and I thank you very much for watching.
Now that we've seen the actual demo of the kit in operation, let's talk about the system itself and how it's all put together. I have a block diagram in front of me here, Steve. Maybe you can talk to it and the various boards that make up the kit.
Sure. Well, if you look on the block diagram, that main block is the Cyclone 3 FPGA. And if you take that block and you add in the PHY, really what you get is you get the main firefighter board. You know, over here we have all the connectors that are going to the computers or Ethernet, right? And we also have over here the connectors that would be going to the driver boards.
The fire driver board.
The fire driver board. So this is the fire driver board, and obviously we need a separate fire driver board for each motor.
Ah, okay.
The kit comes with the fire driver board and motor. It comes with the cable connect to your computer, and it comes with all the documentation and software necessary.
And this comes with the source code,
One more
too,
point,
right?
yeah, that actually includes all the source code for the control of those motors.
Thank you very much. It does,
That's
and that
great.
is very important to help get your product to market quicker, is to have all the source code. You can modify it very easily.
Gives you a great starting point for your own designs there.
Yeah.
Thank you.
Let's talk about each of the boards in more detail. I have another block diagram here in front of me of the firefighter board itself. I see immediately the Altera Cyclone is the primary block here.
Yeah, the Cyclone 3, and again, we chose that device family because of the low power consumption. And the smallest member there, the 3C5, consumes 35 milliwatts of power at room temperature, so static power. So very low power family, an important consideration for these types of applications.
Yeah, I also see that National's power converters and the PHYs were chosen as well, which are very low power. And Stephen, you want to talk about the rest of these peripherals around here a little bit?
Well, I mean, obviously, since we're doing motor control, in this case, 6 different motors, you know, the Cyclone is talking to those, but we also needed some more I/O expansion just to bring out general purpose I/Os for other things. So that's really the purpose that other Max 2 is on there.
Altera Max 2 on here as well. I see it has DDR2. Because of the embedded Neos processor, you need all the processor type things. You need memory and you need flash.
Sure,
is that correct,
absolutely.
Jeff? Okay, and I see you have all kinds of interface components on the left-hand side as well to get you connected to the outside world.
And again, the national power converters are there as well.
Yeah, everything was chosen for efficiency.
Highest efficiency. Let's take a look now at the actual fire driver board block diagram. Steve, why don't you talk about this a little bit? I see another Altera Max 2 in the center there.
Again, it's for I/O expansion. You can see all the different A to Ds that we have on there, and we only have one little connector off the far side. So we're really multiplexing the signals that come into the Max 2. And you can also see National's gate drivers.
Oh, yes. Yep.
We've chosen there.
Okay. I'll tell you what, let's take a look at the overall system diagram again. And Jeff, why don't you give us a little bit more detail on what's actually in the Cyclone 3?
Yeah, if we push into the Cyclone 3 device itself, you can see the Neos 2 processors there. And again, 2 Macs are shown wired up to it. There is an entire set of peripherals around that Neos 2 processor, and that's one of the compelling things about Neos 2 is you can customize that peripheral set, as we mentioned earlier. In addition to that, you've got your HDL motor control and I/O logic. It's shown there just wired up to one fire driver board. But again, one of the things about using an FPGA is you can hook up multiple fire driver boards or multiple motors in order to control different elements of your system. You can control multiple axes, have other custom logic in there for your field bus communications, and really complete your system all on the same device.
So the fact that everything's in one FPGA, you can coordinate all this motion because the system knows where everything is.
Exactly. Everything's happening on the same device and interconnected to the same intelligent host that's residing on that FPGA.
This is great. So Steve, where would we get this kit? How do I get one?
Well, you can contact your Arrow sales representative and they can help you get a kit. You could also go online and look at the URL shown on the screen there, and you can do it that way too.
Okay, super. So basically what we've learned is that by using an FPGA in these type of applications, it gives you a lot of flexibility in your design. So if you're building any kind of motion control thing, you have the ability to embed not only the processor in there, but all the control logic and everything would be required to drive the motor. Also, because it's a soft solution, it has longevity, which is important to a lot of the customers that you have that are going to remain in manufacturing for 5 or 10 years, especially in medical fields or industrial fields where they had to pass certification.
It's all about flexibility, integration, and longevity.
That's great. I'd like to thank you, gentlemen, for joining me. Jeff Wemmitt with Altera and Steve Herhusky with Arrow Electronics. Thank you very much, guys, for joining me, and thank you very much for watching.